and hydrogen. So ethanol reacts with sodium to give sodium ethoxide, and hydrogen gas is produced over here. So this is the first chemical property of ethanol. The other alcohols also behave the same way. This is methanol reacting with sodium. We get sodium methoxide along with hydrogen. The logic is the same. One hydrogen got replaced with sodium. For ethanol, we have just now seen in the previous slide also. Same thing happens with propanol. It forms sodium propoxide along with hydrogen, and butanol, it makes sodium butoxide and hydrogen. So here any alcohol can undergo this reaction. But in your syllabus, you just have to prepare for ethanol. You just have to prepare for ethanol. Now, another reaction we are going to see, this is ethanol taken on screen, and it is reacting with hot concentrated sulfuric acid. Now this sulfuric acid is very strong acid. It is very strong acid, and here it is taken in concentrated form. So what happens is a water molecule gets removed from this ethanol. Water molecule gets removed. So if you remove a water molecule, 2 hydrogen and 1 oxygen, you are left with 2 carbon and 2 hydrogen. You can check over here. This is carbon, carbon, and 4 hydrogen over here. These are 3 hydrogen. This is the fourth one. So you get the compound C2H4. It is a double bond compound called ethene. It is called ethene along with water, because water got removed out of it, right? So when in this reaction, when ethanol reacts with hot concentrated sulfuric acid, we get ethene gas along with water. In this diagram, you can see this reaction happening. This is ethanol with sulfuric acid, and ethene gas is produced here. This is ethene gas being collected here, right? So here, this concentrated sulfuric acid is acting as a dehydrating agent. This is acting as a dehydrating agent because it is removing water out of it. And you have to remember the temperature during this reaction. It reacts at 443 Kelvin temperature. So this is the second property. Now we are going to discuss the properties of ethanoic acid. It is acetic acid commonly called. It belongs to carboxylic acid, and we know vinegar is made out of it. You have to take 5% acetic acid and 95% water. You get vinegar. Sometimes this is taken in 8% quantity also. So vinegar is basically made out of, it is used as a preservative in pickles, and it freezes during winters and looks like glacier. So it is also called glacial acetic acid. Glacial acetic acid. You have to remember the melting point, 17 degrees Celsius. This is the melting point of ethanoic acid. Now let us see the chemical property, how it reacts. You can see here we have taken ethanoic acid, CH3COOH. It is reacting with alcohol. Actually, the formula is this, CH3CH2OH. But it is written backwards so that you can understand the relation, the reaction nicely. See what we've done. We've written CH3, CH2OH, right? So it is ethanol written in the reverse order. Let us see what in exam you have to write it in the proper way. You have to write it the way we write it, CH3, CH2OH. You don't have to write it in this manner. It is just to make you understand. Now what happens is they react in the presence of acid H2SO4. Again, water molecule is removed. water molecule is removed here, or rather you understand it in this way, water molecule is removed. So what happens? Let us see what is left behind. Here we get CH3, okay, then C double O, this CH3 is done, C double O is done, this part we have written C double O, then this water molecule has gone away, this has gone away, so the remaining part CH2CH3 binds with it. This is the water molecule which got removed, right? This is called ester. This is called ester. You can see this nicely what is produced. CH3COO part is from the acetic acid. Let me erase this and make write the equation. See, this is what. This blue part is from ethanoic acid. The blue part is from ethanoic acid and the red part is from ethanol, right? So the name here is called ethyl ethanoate. Ethyl ethanoate is the name of this ester. Actually, this ethyl ethanoate belongs to ester category. Ester is a group of chemicals. It is a group of chemicals. How is it formed? You take any carboxylic acid. You take any carboxylic acid. You can take methanoic acid, ethanoic acid, propanoic acid, butanoic acid, pentanoic acid, any carboxylic acid, and make it react with any alcohol. Methanol, ethanol, propanol, butanol, pentanol, hexanol, any one. Then the same thing happens and we get a compound called ester. So that's why I told ester is a group of chemicals. The specific name will depend on which carboxylic acid is reacting with which alcohol. Right? Here, because ethanoic acid is reacting, we get ethyl ethanoate. See, this part is from alcohol and this part is from ethanoic acid. The first name of the ester is from alcohol and the second name is from the carboxylic acid. If suppose we make methanoic acid react with ethanol, the name will be ethyl methanoate. Ethyl methanoate. Because the second name depends on the carboxylic acid. If it is propanoic acid, if it is propanoic acid, then it will be propanoate. If here we have the alcohol methanol, then here it will be methyl, right? So this is the way the reaction takes place. Because in this reaction ester is produced, we call it esterification reaction. Now, as I told you, esters are a group of compounds which are sweet smelling substances. They are sweet smelling substances and they are used in flavoring agents. This is a list of some esters. They smell like fruits. You can see. So here different alcohols are reacting with different carboxylic acids. Okay. So that was about esterification reaction. Now esters react with the base. This is the ester which we discussed in the previous slide. Ethyl ethanoate is reacting with base. So what happens is this breaks, the ester breaks, the blue part and the red part, they break. This sodium goes and binds with the blue part and OH binds with the red part. So what happens is we get CH3, COO, Na plus CH3, CH2, OH. This is what we get. This is ethanol and this is sodium ethanoate. This is sodium ethanoate. So let us see this. See, sodium ethanoate. Now this salt is used as soap. This is used as soap. And because in this reaction soap is produced, this reaction is called saponification. This reaction is called saponification reaction because soap is produced here. Okay. So ester reacts with NaOH, you get soap and alcohol. Now when we make soap, actually it is a large molecule. You can see how large the molecule is. This is such a large, it is a large ester. So this is the soap, right? Now this you can make soap at home. You just need an ester. So you take any oil like coconut oil. Coconut oil you take and this is NaOH. So when you add, it starts solidifying gradually and you can give it any shape, any color, right? So this was, now this is another reaction where you can see ester is reacting with acid. So you are getting back the things, ethanol and ethanoic acid. You are getting back these things. This is called acidic hydrolysis. This is called acidic hydrolysis of ester. Now, the next is reaction with base. It is very simple. It is neutralization reaction. You can make acetic acid react with base. So, because this is an acid and this is a base, we get salt and water. This is salt and water. So, this is neutralization reaction. And if you make ethanoic acid react with sodium carbonate or sodium bicarbonate, we have already discussed this in chapter 2, we get carbon dioxide along with salt and water. Because here carbonate salt is there, we get carbon dioxide along with water and sodium ethanoate. So these are the common reactions of ethanoic acid. Now let us see some questions based on this. How will you distinguish experimentally between alcohol and carboxylic acid? On the physical property, you can distinguish because it has vinegar-like smell and it has got a pleasant smell, right? On that basis. But chemically, you have to differentiate them. So what you can do is in two different test tubes, you are having alcohol and carboxylic acid. You make them react with Na2CO3. In both of them, you add this. In this test tube, you will see the bubbles of carbon dioxide gas. You will see bubbles of carbon dioxide gas. But here, no gas is produced. So this is alcohol and this is carboxylic acid. Carboxylic acid will give carbon dioxide gas bubbles with sodium carbonate or sodium bicarbonate. Okay. The next one is, what are oxidizing agents? Oxidizing agents are the ones which are responsible for oxidation of other substance. They are responsible for oxidation. The common ones are KMNO4, potassium permanganate. They oxidize the other substance, right? The next question is, how can ethanol and ethanoic acid? The same question. This is alcohol and this is carboxylic acid. This is carboxylic acid. You just have to differentiate them. So just now, but they are asking you on the basis of physical and chemical property. So physical property, I told you, on the basis of smell, you can see this is vinegar like, this has pleasant. And chemical property, you just make it react with Na2CO3. You will see CO2 gas here and no CO2 gas here in alcohol. So this is the answer. Okay. Now, the next question, draw the electron dot structure for ethanoic acid. So, how do we draw it? First, we see this is ethane. Ethane means two carbon. So, let us make two carbon atoms over. It is oic acid. Oic acid has got this functional group, COOH. So, let us make this functional group on the second carbon, and with the first, now you can see all four valencies are satisfied for the second carbon, but for the first carbon they are not. So let us add hydrogen. So this is CH3 COOH. This is the structure. You can have 1 mark question like this. The next one is H2S. So sulfur has got valency 2. So this is how, if they ask you to draw the electron dot structure, then this is how you can draw. You can show 1, 2, 3, 4, 5, and 6 valence electrons of sulfur and 1 valence electron of hydrogen. So you can show them being shared. This is hydrogen happy with 2 electrons, and sulfur has 8 electrons like this. And same for ethanoic acid also you can show. Then propanone. Propanone में propane has 3 carbon atoms. So 1, 2, and 3. And one is ketone. It is ketone. So ketone is C double bond O. So let us put double bond O over here and 3 hydrogen atoms with the first carbon and 3 hydrogen atoms with the last carbon. CH3, CO, CH3. This is how we draw it. And finally, fluorine F2. This is how fluorine is drawn. It has 7 valence electrons. So you can, okay. Now mixing oil and water. This is the test tube having oil and water. They do not mix together. They just stay in 2 different layers. However you stir them, still you will see them in layers. This is oil over here and this is water because they are immiscible. This is situation 1. Now in situation 2, we are having oil, water and soap. We are having oil, water and soap. Let us see what happens. See, this is what has happened. So what has soap done to oil and water? So let us see now. Soap, now this is the comparison. This is only oil and water. This is oil and water with soap. Soap is a linear molecule. It has 2 ends. One is hydrophilic, the other one is hydrophobic. This is the soap molecule you can see here. This is the head part, hydrophilic part, and the tail part, hydrophobic part. So what happens is, when you put soap in water, they make a sphere-like structure. They make a sphere-like structure in such a way that all heads make the surface and all tail make the inside of the, you can see this is the sphere. These all heads make the surface. See, all heads have made the surface and all tails are inside. So what happens is, when they are doing so, they are trapping the dirt or the organic dirt into it. So in when they do this, they are staying away from the water, and they also do the cleansing action. You can see this diagram. You can see. So this is how the soaps work. All the hydrophilic heads are in contact with water, and hydrophobic tails are away from water. Such a structure is called micelle. Micelle is the three-dimensional spherical structure. You can see this is a cloth having some stain on it, this one. This is the grease or the dirt on it. This is cloth. And these are all the soap molecules. They are coming towards the grease and they are trying to pull the stain away from the cloth. So this is how the stain gets pulled away. So micelle formation takes place so that the cloth can be cleaned nicely. This is another diagram of the same concept. You can see the animation. The soap molecules are taking away the dirt by making the micelles. All right. So they make a emulsion kind of. You must have studied in class 9 colloids, emulsion. Okay. So this is the now the question is, why does micelle formation take place when soap is added to water? We have discussed the reason, because soap molecule has got two parts, head and tail. Head is hydrophilic, tail is hydrophobic. It wants to stay away from the water, so it makes it. Ethanol will not make the micelle formation take place because the chain of soap is soluble in alcohol. So this is the similar question, how does cleaning takes place? So the answer is the same. Now, hardness of water. Water is hard because of calcium and magnesium salts present into it. These are calcium and magnesium salt which make it hard. So it is difficult to get foam in this water. You will keep on applying soap on your palm, but you will get foam with difficulty because already calcium and magnesium salts are present into it. In fact, it will keep producing insoluble substance which is called scum. Scum keeps on getting produced. So it is difficult to do the cleaning in hard water with soap. That is why detergents are used in hard water. Chemically, soap and detergents are different. Soap is sodium or potassium salt. Sodium or potassium salt of long chain carboxylic acid. Long chain carboxylic acid. This is soap. But detergents are ammonium or sulfonate salt of long chain carboxylic acid. So they do not form scum. They do not form precipitate in hard water. So it is easy to use them. So here you can get a question asking what is hard water? Hard water is the water which is having calcium and magnesium salts present into it. And what is the difference between soap and detergent? Soap is sodium or potassium salt of long chain carboxylic acid, whereas detergent is ammonium or sulfonate salt of long chain carboxylic acid. And what happens when you use soap in hard water? You can write scum is produced, which is insoluble precipitate. It is produced because calcium and magnesium salts present in hard water react with soap. So all shampoos are detergent based. That is why you will not find it difficult to use shampoo in hard water. Now we have some questions. Explain the formation of scum. So I have just now explained you what is scum and why it is produced. You can read the answer. Then would you be able to check if water is hard by using detergent? No, you can't check it because detergent will work equally well in hard or soft water. So you won't be able to check it because as I told you, they work equally well in hard and soft water. People use a variety of methods to wash clothes. Usually after adding the soap, they beat the clothes on a stone or beat it with a paddle, scrub with a brush, or the mixture is agitated in a washing machine. Why is agitation necessary to get the clean clothes? So the answer is simple. Here the micelle formation takes place when you add soap in water. Now when you agitate in any way, either in washing machine or by paddling or by scrubbing it with brush, the micelles get disturbed, they get broken, and again they want to make micelles. So it keeps on happening. Micelles are formed, they are broken, they are formed, they are broken. And when this is being done, every time they are pulling the dirt away from the cloth. So the cleaning is good. So agitation is necessary when the clothes are being cleaned. Now, what change will you observe if you test soap with litmus paper? We know soap is basic in nature. Soap is basic in nature. So it will change from red to blue. And blue remains blue. There is no change. Then ethane with molecular formula C2H6 has how many covalent bonds? So this is ethane. This is the structure. You can check how many bonds it has. So it has 7 covalent bonds. This kind of MCQs can come in exam. Then butanol is a 4-carbon compound with which functional group? So we know butanone has ketone, C double bond O. So it is ketone. Then while cooking, if the bottom of the vessel is getting blackened on the outside, it means which one? Take your time and think and you can answer the question. It is getting blackened. Remember we discussed this concept yesterday. Would you like to unmute and answer the question or you can write in the chat box? It is getting black. If you remember yesterday we discussed there was a candle and it was making the spoon black. Any answer? B. Good. The fuel is not burning completely. Very good. It was incomplete combustion. Okay. So this is the end of the chapter. Uh, if you have any doubt, you can ask. In case any doubt, you can ask. Any doubt? Yes, 1 minute. Let me check. No doubts. Okay. Okay. So I hope you know the making of structures the way we did on the first day for alkanes, alkenes, and alkynes. Please practice those structures nicely because they ask the diagrams of those structures. There is a small topic of nomenclature. We can do the recap of that. How to name the compound, the branched structure. It will take 5-7 more minutes to understand this. See, this is the parent chain and this is the branch, right? This is the parent chain. Let me just, and this is the branch. B, R, A, N, C, H. Now, parent chain has 3 carbon into it. For 3 carbon, we have the name prop. Okay. And all single bond are there. So the name is propane for the parent chain. Now in branch, there is 1 carbon. For 1 carbon, the root name is meth. But because it is the carbon of branch, we call it methyl. So the name becomes methyl propane. And this methyl is located on the second carbon, see, 1, 2, and 3. So we call it 2-methyl propane is the name of this compound, 2-methyl propane. Okay, let me check. Let me check. Just a second. Now I hope it is visible. Just a second. So this is what we were discussing. This one. This is the parent chain, this one. And it has 3 carbon. So for 3 carbon, we have propane, right? And this is the branch, this one, B, R, A, N, C, H. Branch has 1 carbon into it. And the name of 1 carbon is meth. And because it is branch, we call it methyl. So it is methyl propane. And this methyl is located on the second carbon, C1, 2, and 3. So we call it 2-methyl propane is the name. Don't go into what is written here on screen. It is too complicated. You just remember what I explained you just now. This is called 2-methyl propane. The name is simple, right? Similarly, let us see. See, this is the parent chain, this one. It has 4 carbon into it. 4 carbon. 4 carbon name is butane. And this is the branch, this one. Branch has 1 carbon into it. And for 1 carbon, we know it is methyl. So the name is methyl butane. Now you can see it is located on the second carbon. So the name will be 2-methyl butane. 2-methyl butane. right? Uh, I hope you are understanding. Now here, this is the parent chain. Parent chain has three carbon atoms, so propane. Now this is branch, methyl. This is also branch, methyl. We have two methyl here. We have two methyl, so we call it dimethyl. Dimethyl. And both are located on second carbon, so we call it 2,2 dimethyl propane is the name, right? 2,2 dimethyl propane is the name. Now this is 2-methyl butane. This is, you can see, 1, 2, 3, 4, 5, and 6. 6 is hexane. 6 is hexane, and there are two carbon in branch. There are two carbon in branch, so it becomes ethyl. 3-ethyl hexane. Okay. This is 1, 2, 3, 4, 5, 6, 7, 8. If we count like this, the branch is on sixth carbon. But if we count reverse, 1, 2, 3, 4, 5, 6, 7, 8. The branch is on third carbon. So this is the correct way of counting. This is not the correct way of counting, because a rule in chemistry says that we have to count in such a manner that the branch gets least number. So when we count this way, it is getting number 3. And if we count this way, it is getting number 6. So this is the correct way of counting. This we will, let me just cut this one, right? So the name is, because there are 8 carbon atoms, it is octane. And the branch is on third one, so this is 3-methyl. 3-methyl octane. Okay. Then this is 2,2-dimethyl propane, we've just now done. Now here this is 1, 2, 3, 4, 5, 6, 7. This is 3-methyl heptane. Okay. Here this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is nonane, and there are two branches over here. This is one branch, this is another. So this is diethyl. One branch is on 4, the other one. So this is 4,5 diethyl nonane. Right? So this was the nomenclature, how to name the compound. Now any doubt in this one? If any doubt, you can ask, or else we'll wind up. Okay, so I think no doubt. So we can wind up for the day. Okay, so bye all of you. I'm winding up. Thanks for joining. Take care.